Hello, everyone, and thank you for joining us for today's e-showcase, an integrated approach to storm, water, and flood management using InfoWorks ICM and HEC-RAS. I want to take a moment to thank today's sponsor, Autodesk. Thank you so much for sponsoring today's event. And I actually have the pleasure of introducing today's presenters, Yusuf Al-Fahim, who is a Senior Technical Marketing Manager for Autodesk, and Mary Whitehead, Principal Engineer for Arcadis. And now I will hand the presentation to our presenters.
Awesome. Thanks a lot, Regina. I'm going to share my screen so we can kick this right off. Share. Is everything working fine? Mary, can you confirm?
Yes, I can see your screen.
Awesome. Well, thanks a lot, Regina, for the introduction. Thank you, all of you, for joining today and for joining us in this very exciting webinar. We're going to get to the content very shortly, but before we get to that, just had the safe harbor statement that I wanted to point out very briefly, which just indicates that if we make any forward-looking statements, we don't want you making any purchasing decisions based on those. So as Regina has introduced, I'm Yusuf Al-Fahim, a Senior Technical Marketing Manager at Autodesk, and with me is Mary Whitehead, the Principal Engineer working with Arcadis. So going to the next slide. Interesting. Sorry, just give me 1 second. I just lost control. Okay, apologies. There. Yeah, I think it should be working fine. I just lost control for a second. But the agenda for today that we're going to cover, we're going to first start by introducing a background or the why of why this topic is important. We're then going to get right into the case studies, which are going to be given by Arcadis, some of their case studies and some of the exciting work that they have been doing nationally. First, we're going to cover a case study in the City of Fayetteville in North Carolina, and then we're going to cover another case study with the City of Houston in Texas. Then we're going to wrap up with some resources and Q&A at the end. So all questions we'll attempt to answer at the conclusion of the webinar. So the background. There are a lot of challenges facing the stormwater and flood industry, and what we're going to attempt to do here is just showcase some of the statistics that are quite stark, and they can lead us to understand how big of a challenge that we have at our hands here. So 16 to 24% is the expected increase in precipitation globally by 2100. $4.8 billion is the average cost in damages per extreme flooding event in the US. Some more statistics that are attributed to climate change. So $1 trillion is the annual global impact cost of rising seas and inland flooding. And then 800 million is the expected number of residents impacted by 2050 due to coastal flooding and storm surges. So there are quite a bit of challenges that we're facing, but it's not all rain and clouds. There are actually some opportunities as well, specifically pertaining to digital technology. So $223 billion is the expected funding over the next 10 years dedicated to the digital transformation in the water industry. Also, 60% of water utilities are expected to undergo various sorts of digital transformation by 2025, which isn't that far away. Now, in the context of digital technology, we're going to talk about 3 primary solutions in the context of stormwater and flood today. First are going to be the U.S. Army Corps of Engineers HEC software, primarily HEC-RAS and HEC-HMS, and Mary is going to touch quite a bit on those. And we're also going to be covering InfoWorks ICM by Autodesk, and also Mary is going to be talking about the application and how all these solutions come together to serve stormwater and flood management. Now, if you're interested in getting to read more or getting more exposure to HEC-RAS and InfoWorks ICM and how they're used together and what some of the advantages and limitations of each are, you might be interested in checking out this blog. by my colleague Trevor. So it's HEC-RAS, talks about its history, benefits, drawbacks, and alternatives. So that's a good read if you're interested in that. That said, that concludes the introduction portion, but we did have two quick poll questions just to get your feedback. So we wanted to ask you, what is your modeling software of choice for stormwater and flood management? We're going to give you just a few seconds to answer that, so probably just 60 seconds or so to answer that. And I am aware that the options to pick from are quite a lot. So I'll give you, ample time to read through them and answer them accordingly and pick your choice accordingly. A lot of good responses so far. Seeing a lot of people that are using a good mix of commercial software and HEC software. And we're just going to give you about 10 more seconds and then we're going to end the poll. So just 10 more seconds to respond. Awesome. And we can end this poll and we'll move to the next question. So we're just going to move to the next slide here, which is what pertaining to modeling software. So what factors are most important to you when selecting modeling software for stormwater and flood management? So the question should be popping up shortly, and then I'll just give you about a minute or so to answer that. I do not see the question popping up on my end, but Regina, if you can confirm that it's up and running, that would be appreciated. Okay, I did not hear from Regina or Mary. Can you confirm that the question is running?
Yes, it is running. We are about
Okay.
to close it in just a moment.
Okay, very good. Just let me know when that's done.
All right, the poll is closed.
Very good. Thanks a lot, Regina. So thank you all for responding to and engaging with us through these poll questions and giving us your insights and feedback there. Now we get to the case studies by our Arcadis. So Arcadis is an international consultancy. They do a ton of work globally, but for today, they're going to focus on two national case studies, namely in North Carolina, in with the City of Fayetteville, and in Texas with the City of Houston. But before we get to that, also, we just had one final thing that we wanted to ask you about pertaining to what do you see being the top area of concern in stormwater and flood management? Because you're going to see some examples given by Arcadis, but we want to get a sense of what are your primary top areas of concern in stormwater and flood? Is it aging infrastructure, urbanization, funding, climate change, or regulatory requirements?
And the poll is open.
Very good.
And as Youssef stated, we'll give you about 60 seconds.
All right, just a few more seconds for that poll. So if you have not responded, just get in there and put your answer in, and then we're going to move right into the case studies. All right, I think we've ended the poll. Thank you again, all of you, for responding. And just looking at the results very quickly, it seems like there's a heavy emphasis on aging infrastructure and increasing urbanization. So thank you all for that feedback. And that said, I'll pass it on to Mary, who's going to walk us through the two case studies mentioned here. So first starting with the City of Fayetteville, and I'll hand it over to Mary now.
Okay, thank you.
Let's see, I think
Okay, so our first case study will be the City of Fayetteville, North Carolina. What I'll do is start with some background on the project and then kind of roll into how we used the different softwares. So for the City of Fayetteville, overall, in the last several years, they've experienced a significant amount of flooding due to hurricanes, as well as just an increased rainfall that they're seeing on an annual basis. So the city decided that they wanted to be proactive, and they wanted to study their watersheds. They wanted to do detailed analysis on areas they deemed to be priority, and they wanted to create models as well as move it through planning level capital improvement project development. Overall, there are 15 watersheds to be analyzed. The city rolled it out in multiple project groups. We were part of the first group, and our modeling project was Bounce Creek. Each watershed, it was a two-phased approach. The first phase was to create the model and validate it, and then the second phase characterizes the system and find concern areas is what we called the areas that we felt should move forward into project development. The second phase was to take the concern areas that the city identified should move forward and develop planning level projects. So prior to the rollout of the first set of watersheds, the city worked through with several area consultants the pros and cons of the 1D and the 2D H&H models. So they went through the process of determining what software to use, and beyond what software to use, potentially whether or not you wanted to combine it into one model, if we wanted to do two models, how that would work out. They were doing a holistic approach to the watershed. So it was not just closed system analysis, but it's also, they wanted to see how the closed system and the riverine system work together, the primary and the secondary systems. Ultimately, in the end, after their pre-program workshops, it was determined that they would move forward with HEC-RAS for the primary system and InfoWorks ICM for our secondary system. The model build has noted the primary riverine system. We used a steady state 1D HEC-RAS model for the hydraulics. We did investigate 2D modeling as well, but it did not move forward into project solution development at that time. And then we used HEC-HMS to represent the hydrology, as the city had an existing HEC-HMS model that they had used in their pre-program workshops. The secondary collection system, we used InfoWorks ICM for the hydrology and the hydraulics. ICM was very helpful in that we could utilize the workgroup functionality to streamline, because it was a large watershed. It covered a good number of sub-watersheds within it. So therefore, we had a multiple model team. As you can see here by the various colors, there were at least 4 modelers working on it at the same time. So this enabled us to work in one area. In order to ensure that the flows made sense and would correlate between ICM and HEC-RAS, we actually worked to match the HEC-HMS flows to the InfoWorks ICM flows. That was the first way we worked to kind of incorporate the two programs together to ensure that they were both seeing the same impacts. The model build for ICM, we initially did the 1D model development, and then adding our 2D surface, we extended the 2D zone by using the 100-year flood extents, as at the time that was the largest event we would be analyzing. We incorporated buildings. They were used as porous polygons. For this model, channels and ditches were modeled as voids with 2D nodes on the upstream and downstream end. And to ensure that we weren't sending water around the void and it was missing the ditch altogether, we looked at periodic places throughout the ditch where we thought there may be lowest points and added additional nodes and additional locations for flow to kind of move around the surface and re-enter the system. Now, the boundary conditions, when we were doing our initial level of service designation, we used a free outfall condition because we wanted to just identify what the secondary conveyance system could handle outside of its impact from the primary system. Once an area moved forward into proposed solution development, then we would actually work with the primary system modeling team and identify appropriate boundary conditions to use. For the HEC-RAS model development, one of the reasons that HEC-RAS was selected for the primary system model development was there were available pre-preliminary models of the major streams that we were going to be analyzing in each watershed. Therefore, each team wasn't starting from scratch. They were able to take this baseline model and update it with additional survey. The city was very thorough, and they surveyed their entire secondary system as well as the primary system within the particular areas that they were highlighting, the priority subbasin areas. So the HEC-RAS models were reviewed and compared to the survey data. Updates were made, and in many cases, the existing HEC-RAS models were expanded farther up into the system to ensure that we were modeling all the primary systems that were impacting any of the priority basins or areas that we were doing some heavy analysis inside of. So once all the models were built, we ran them for the typical design storms, 2, 5, 10, 25, 50, and 100 year. And we took those results in two pieces. So the first piece was the ICM model results. So the ICM model results would come out using, would provide us with the level of service for each of the pipes and the nodes. And we also used it to identify street flooding and building impacts. On the flip side, from the HEC-RAS model, we pulled out the raster files to provide the water service elevations and the depth of flooding along the streets. And it helped guide us through building flooding as well as street flooding. So in the end, the big thing was to bring both of these together. So we brought the raster files from HEC-RAS, incorporated them with ICM rasters, and then we used those to finalize our building impacts as well as identify street flooding. And what you'll see here is you'll see these black polygons. And what those black polygons are is based off of the flooding noted in both the primary system modeling and the secondary system modeling. We were able to identify these areas as having needing to move forward into a proposed solution development process. These were defined as areas that had significant surface flooding. The system was very much undersized, and the buildings, we had a significant number of buildings not meeting the city's required levels of service. The city was very good about putting together a whole process to identify the levels of service that they were looking to reach in all the systems. So once a concern area was identified, then we moved forward to scoring them. The things that the city was interested in most were street flooding, building impacts, essential facilities, disconnected dwellings, which is number of people who may live inside a community or something that only has one road and are out, and therefore if that road gets to a certain level of flooding, they cannot be addressed. They cannot receive emergency services. So those were areas of import to the city. So scores were assigned to each of those. As I said, the city set out a very detailed process as to where they wanted to designate and how they wanted to assign scoring to the different categories. So once all those scores then were rolled up, they rolled up into a total score. In some cases, there was an additional weight added in order to process things that they found were more impactful to them or more of a risk, like traverse road crossings and essential facility impacts. Those are deemed kind of a higher, they were more, prioritized. Therefore, based on the score, each concern area was categorized into low, medium, or high. Anything that was at medium or high was essentially initially identified for potential projects. The city would then receive this worksheet in addition to all the maps that showed all the surface flooding, and they would evaluate each concern area and determine which ones to move forward into proposed solution development. One of the interesting things, and I think was very important here, is even though the models were done separately, and they were done separately because we had the HEC-RAS models were available, but it was also the city wanted to keep the door open for them to potentially, if they needed to submit later down the road to FEMA or any other government organization, they knew that they could submit, they would have the HEC-RAS model developed. So that was one of the reasons they wanted to keep them separate. But in this case, we were able to bring all the results from those models together and come up with kind of cohesive concern areas that were not only primary system driven, secondary system driven, but they included impacts from both. So one of the big projects that came out of that is actually moving forward at this time was a primary system solution focused. It is focused downtown on Blunt's Creek. It includes expanding 2 bridges, as well as a railroad, actually 3 bridges, a railroad bridge, and then Russell Street and Person Street, doing a significant expanse of widening those bridges, as well as doing stabilizing, restoring, and doing additional floodplain storage in the downtown and areas where we can facilitate some additional storage. There could be some additional expanding or widening of the existing creek to enable flow to kind of move further downtown, because we were finding that there was a concentrated effort of surface flooding in our downtown area. Overall, that was a $22 million project. What was nice was that the city applied for and received a BRIC grant funding. So they were able to subsidize quite a bit of the project cost with a BRIC grant. You'll see here, this shows on the left-hand side is the existing condition flooding. As you'll see, the flooding expands well up into the system. And then on the right, the project is in this area here. And you'll see that's where you see the most impact, especially down in this area, is significantly reduced and was significantly reduced downstream to pull everything inside the banks. In this case, it enabled us to help additional secondary solutions in this area to be more effective, because we were finding that, especially in the downtown area, we needed to have a primary solution coupled with a secondary solution to really make that, to really make any sort of investment in those areas effective for the city. Otherwise, they weren't seeing as much impact as they would, which would make not spending money in that area not as helpful. So that was kind of one of the other reasons that they wanted to do this holistic approach, was to ensure they weren't investing money in places based on just their knowledge of one system, that they were doing it based on their knowledge of both systems, so that they ensure that any projects they move forward with are effective. So overall, the project goals for Fayetteville, they wanted to mitigate surface flooding. They wanted to address kind of the problems they were seeing regularly, and they wanted to implement a strategic plan that would go in place and help them to be more resilient as the weather changes and the hurricanes and things like that. As this weather is getting more extreme, they wanted to kind of be proactive and be thoughtful in the projects that they were moving forward in their stormwater system. The HEC-RAS system, as I mentioned, that they were kept because, one, it was a nice place to start to streamline the process, is that there were existing base models to use. But the secondary part was that if they wanted to go through and do any sort of LOMARs or CLOMARs or do any sort of floodplain changes, they would need a HEC-RAS model to move forward into that development with FEMA. The InfoWorks ICM model worked well. It had the nice work group capabilities, which allowed us to work a single model, work with in one overall database. At the time we did the initial program, we were not in the current versioning. So now in the more recent versionings, we are able to use the cloud function as well, which has been nice. So that's kind of the Fayetteville project. So I said the Fayetteville project was HEC-RAS was used and ICM was used. They were kept separate, but the results and the finality were kind of brought together to ensure a holistic approach anyway. So now we're going to move into, I forgot, sorry. There's also, Autodesk did a feature article on the Fayetteville, if you'd like to read the project and exactly, what was done, where the city saw benefits, and how they're going to move forward from this as well. So then that will take us into the city of Houston. So the city of Houston has also experienced a significant amount of extreme weather. They have had a number of hurricanes in the last several years, and they've seen quite a bit of surface flooding, quite a bit of infrastructure impacts. So therefore, what they were looking to do was they wanted to develop a citywide stormwater model. So the stormwater model would be built within the Houston city limits, but it would also be multiple watersheds, because the city of Houston is very large and covers a larger number of watersheds. The project that we were involved in, or the watersheds we were involved in, were these 5: Clear Creek, Armand Bayou, San Jacinto, Loose Bayou, and a portion of Greens Bayou that dealt with the airport. This system, the way they did it is they were actually combined they actually brought the HEC-RAS modeling into ICM. So we did storm sewers and unstudied channels were 1D, but roadside ditches and studied channels were 2D. What this means is a studied channel and unstudied channel. Unstudied channel was a channel that did not include a FEMA model, or they did not have any HEC-RAS modeling for it. So the city wanted to include it as a 1D component inside their model so that they could really see how the water surface elevation changes and how it impacts the system upstream. Study channels were anything where currently the floodplain mapping modeling that's being completed right now, there was already a model that existed for that area. So therefore that was brought in more as burned into the DEM, brought in more as a 2D component. On the hydrologic side, we used rain on mesh within the city limits. However, external to the city, there were a number of locations that fed into it, a number of watersheds and tributaries that fed into the existing systems. Therefore, we use traditional subcatchments outside the city. They said for this focus, they really wanted to focus on the interior City of Houston limits and ensure they were accurately representing that system. This is a visualization of how rain on mesh and ICM, how they bring together the multiple layers and they work together and the rain is applied. This is very helpful. It was good. The city wanted to use this because it does end up, just dropping the rain onto the surface and allowing the surface to really route the water to where it needs to go in the system. This is very applicable though. I mean, you really do need to have a very good DEM, I think, to use the rain on mesh. That is something to keep in mind when you're using this. It's a very good function, but it really is very, you need to make sure your DEM is in a good shape. So as I mentioned before, there were 2 components to this project. There was the model build, the 1D and 2D, and then we also completed a validation of the models. So the 1D modeling noted before was the storm sewers as well as unstudied channels. And the 2D modeling focused on updating the DEM to include roadside ditches as well as any sort of studied channels or bayous. What you'll see here in this graphic of the storm sewers, the city, because we were using rain on mesh and we're routing the water over the surface, we want to ensure that the water can reach the applicable low points, which are where your catch basin is, but they did not want to model the system to the catch basin level because these models are going to be larger and they were looking to make sure we were able to run it in appropriate time levels. So what we did is the system, so you see the system on the left here, is those are the inlet locations. And you would see here, if we move, this was the main trunk sewer. So we wanted to keep the main trunk sewer, but relocate these nodes into the lower levels. So that's what this will see is we put together a tool working within ArcPro that would relocate these manholes along the main line, but still kind of keep this main line, but just move the manholes into these low-lying areas to ensure that the water that's falling on the surface is getting in the system. Because if it's not able to get in the system, that kind of goes against what it is that we want to be able to do. Now for the validation events, each area chose 3 events. A significantly high event, like a Hurricane Harvey. A second rather extreme event, the City of Houston has a number that they have tracked over the last several years. And then potentially, if you can, a more in-bank opportunity, because that would really give them a better idea of what their in-system capacity is and what level of service they're seeing. Now, for the available data, the reason I called it validation, not a calibration, is we did not use flow metering data. So there was no flow metering data available for this system. As a stormwater system, typically a lot of times you don't have flow metering data. So in this case, you're reliant on complaints, flooded structure information. For Hurricane Harvey, we also had available trash pickups, so you can kind of identify where there are large functions of debris with the identity that there could be, significant amount of flooding in that area. So what you'll see here, what they were looking for to achieve the validation was that 50% of the flooded structures matched and 75% matched to the flooded parcels. So as I mentioned, for the 1D channels, or the 1D channels in InfoWorks, We did cross sections every 200 feet. We did not have survey of the channels, so we were reliant on DEM to build the cross sections we needed. We did go out and were able to do survey on major structures that we did not have as-built drawings for or GIS information on. So culverts, any sort of check dams, and bridges. Those were all collected in the field so that we could accurately represent them in the model. But the City of Houston also does have a very thorough GIS system that tracks, and then they were able to provide quite a bit of information with using as-built as well, which was very helpful. So inside this model, which kind of made this a much more complicated system, was we had these 1D channels, and in some cases they were going 1D channel to 1D channel, but in other cases they were going, 1D channel to a 2D channel, to a 2D system. So there was a lot of different opportunities to use kind of almost all the functionality, 1D, 2D functionality inside ICM. So we modeled all the bridges, we modeled culverts, we modeled all the 1D network. Typically we did about 36 inches and larger. They didn't do a full system model. They did so, but still it was an extensive model. And so that was kind of added to a lot of the it was a very complicated, elaborate, complex model, but it accurately represented all the different components of the stormwater system, the primary and the secondary, as well as the intricacies inside the City of Houston system. One of the big items we had in our areas was the roadside ditches. The roadside ditches were burned into the DEM. We did this using RAS Mapper, which we found to be kind of a very effective way of updating the DEM. I know there are different ways that people do it. We just used RAS Mapper. The way that we burned through the driveway culverts. The way those are represented, though, to ensure we weren't really, we were still taking into account any sort of change in flows as they go through those culverts, is we updated the roughness zones so that the roughness zones would identify when there was a driveway, so that we were getting that into account. And the areas where we did break lines for this on the banks, in the center, and then in many cases, if we could, if there was enough room, we tried to do break lines on the along the toe of the roadside ditches. This is also what we did for the bayous and the creeks, the study channels. This is just another kind of view. One of the big things we found with this modeling, because there was so much data going in and there were so many different complex components between the 1D and the 2D, is that we did quite a significant amount of work in GIS prior to bringing everything in, because you needed to make sure you knew where those sun lines were. They were placed correctly with the aerials, they were placed correctly with the DEM, because if they're not placed correctly and the water falls on the surface, it's not going to get where you need it to go. So this was kind of a big component of what we needed to do. So moving into the validation. Now the validation is where we saw the crossover with the HEC-RAS. So as I mentioned, inside each model developed, we burned in any study channels into the DEM. Those are represented there, and we put in break lines to kind of convey the flow downstream. However, many of these were not the full watershed. Therefore, we used the existing HEC-RAS models that are under development right now, and we pulled inflow conditions and level conditions to ensure that we were receiving the correct inflow into the watershed through the bayou, and we were representing the correct boundary conditions. This is particularly applicable when you're looking at something like a Harvey or one of the larger events where the impact of the bayou is quite significant, and you also see quite a divergence between your secondary system and your primary system. Because the model was so complicated and they were so much larger, we actually broke down some of the watersheds into multiple models in order to improve runtime. So in order to ensure that we were accurately representing the interaction between those two submodels, we also added in these flow exchanges. We identified areas where we thought a significant amount of water would be going from one submodel to the next, and therefore we added 2D result lines and pulled those. We also worked with, there were a number of other consultants doing other watersheds, so we also coordinated with them to ensure that we were accurately representing any of our water going into their system or any of their water coming into our system. One of the big things we noted, and it was interesting having everything kind of in one model because you could kind of see it all together, is that for these extreme events, as you would expect, your primary system drives your flooding. However, because in many cases, what we were modeling, particularly one of our locations, was kind of at the downstream end of the system. Therefore, we were receiving flow from upstream areas, and we were running our model. We were running it through Harvey. We were trying not to extend it well beyond Harvey because the model runtimes were, long, and the longer you ran it, the bigger chance you had for instabilities. But in this case, for these events, we had to extend those runs sometimes more than like 3 or 4 or 5 days because the actual peak water surface elevation through the bayou wasn't noticed until much, much later after the event. So it was good. In this case, it was interesting having a model that had everything in it together. So you had one place where you look for everything. The things you have to keep in mind, though, in that case is the runtimes start getting extensive. So you end up having to break them into smaller groups, which is fine once you take into account flow exchanges and you make sure you have your inflows and your boundary conditions. The other thing we ran into more so with the Houston model with all the different 1D, 2D components and interactions and everything is that there's also an extensive amount of troubleshooting you do to make sure that the model can run, that the model can move to completion, because in some cases, it may be that you have to make sure all of your 2D components are hitting the surface, they're under the surface, and there are different things that you need to troubleshoot. So that was kind of a little bit more involved on this project than in our project. So overall, what our the program goals was to develop this model that was relatively validated, and the city now has it in their hands, and they can now move forward and determine how they want to use it in the future. They are, for capital improvement planning or just for assessment. At this time, they may, it was set up to a point where they could also expand the model into other areas if they want to model more of the city. The technology selection, we used HEC-RAS for the inflow and boundary conditions to ensure that we were showing everything we needed to do. The one thing we also had with the interior boundaries, like I said, we did the 1D channels, or the unstudied channels were done in 1D, so the city can really identify what the system is doing there. But anything that was already studied, we just made 2D because the city already has the other representative models, but this still enables them to see how the primary system will interact with the secondary system in real time, which is very helpful. The InfoWorks ICM was helpful with the 1D, 2D capabilities. As I said, I think we used every component that is available inside ICM to do this model. And it was also helpful to have those work group capabilities so that we were able to, because this was a very large undertaking. So we had a number of modelers working on it to work together. So that was very helpful. However, this model was also completed prior to the cloud, so we were not able to use the cloud capabilities for here. So I will turn it back over to Yusuf.
Awesome. Thanks a lot, Mary, for this incredible walk through the 2 projects that you shared. For now, I'm just keeping track of time. We have about 7 minutes remaining here, which should give us enough time to get through the resources and actually answer some questions. So before we get to the resources, we just want to make sure we capture any interest from all of you. We have a poll question, that final poll question, which is, would you like to be contacted by a product expert for an InfoWorks ICM demo? So we're just going to give you 60 seconds or so to answer that, and then we're going to get through the resources, and then we're going to wrap up with the Q&A. So just around 30 more seconds, and then we're going to end the poll here. So 30 more seconds if you have not responded. And we should be heading to concluding our webinar on time here today. And thank you for everyone who has responded to our poll questions. Just 10 more seconds, and then we're going to end the poll. Okay, so we're good to end the poll, and then we're going to navigate forward to some of the resources that we have for you. So first, we're going to start with the learning catalog. So one thing we always want to highlight is the availability of on-demand training content on Autodesk learning catalog. So if you go to the learning catalog, search for ICM, you're going to see many content types pertaining to that, from tutorials to courses to collections. What do each of those mean? We can probably explain that very briefly here. So collections are courses collections and courses are more higher level and longer in length. So we have an ICM course, InfoWorks ICM course that's almost 11 hours, and that comes with the data set and the directions to follow. And then lists and tutorials are more focused and they're shorter in length. So for example, we have a curated list that talks about coupling 1D, 2D river models. That list contains 8 tutorials. Each of those tutorials you can view and you can follow along with the steps. And there are many other lists that you can find online on the learning catalog. So that's just something to keep in mind for on-demand training availability. Next, pertaining to webinars, all our webinars, past, future, are available on demand on the website. So if you just search Autodesk webinars and then you check the box for water, you're going to find all the upcoming webinars. And then we just want to highlight our blog. So if you want to, keep up with everything that we're doing regularly, the blog would be a great place to find us. Which I do want to mention, something recent that we announced on the blog is that all of our hydraulic modeling solutions are now available at no cost to students and educators. You can read more about that on the blog, and it's just simply using an EDU license to access our modeling solutions for a year, and you can keep renewing that year after year at no cost as long as you have an active EDU account. And then also on the blog, you can find case studies, you can find what's new blogs, things that pertain to either InfoWorks ICM or any of our other products. And the final thing is a technical information hub. So in InfoWorks ICM, there's a specific information hub that you can access through the blog, and you can actually subscribe to that, where you can get automated updates when anything is published pertaining to InfoWorks ICM. That is all we have for you, and that would be a good time to actually get to the questions. So, Mary, were you seeing any questions that we could tackle here, or? I know there was a question that came up as you were talking about the City of Fayetteville, asking about the bridge expansions, if that, how that contributed to, I guess, the flood mitigation.
You're on mute, Mary.
Sorry. The bridge widening enabled the system to expand and therefore make the channel wider, and we're able to get more flow through to the downstream end. So it was able to kind of convey and send more and prohibit more flow from backing up and going out into the surface.
Great, thank you. And I know there was another question about the rain on mesh feature, and someone was asking if the 2D cells are treated as their own individual, like, subcatchments or catchment areas. I guess I was getting into the theory of that. I'm not sure if that's something you wanted to touch on, just briefly on rain on mesh in InfoWorks ICM.
Yes, the rain on mesh at each of the 2D cells is treated as kind of like a tiny subcatchment that the flow drops onto and then goes on to where it needs to go. So yes, that is accurate.
Sounds good. And let's see. Someone is asking about the trainings mentioned. Are they free or do they have a cost associated with them? The trainings are on demand and free on our website. Now there was another question. Someone was asking Mary about the workgroup capabilities, how you've used it. So I'll just read out the question and see if that's something we can address. So the question reads, did you save on one employee's C drive and invite users through the cloud service? Or did you store the model database on your company's network drive and then share with collaborators from there? So anything you can mention there?
We actually were able to set up a remote computer that had available. That way any one person wasn't using all of their C drive, because when you run ICM models, the output files are very large. And so that becomes kind of a difficulty in trying to store everything locally. So we were able to run it through a third-party server. When we delivered it to the clients, we actually provided them ICMT files that included results, and then those were distributed to them. So they did not have access to the work group. The work group was only able to accessed by people working on the model, and it was only where the working files were kept. And then, like I said, once they were finalized, they were brought into an ICMT and delivered to the client. Now, when we do it, we are using cloud services. So everything is kind of hosted up on the cloud. But when we do deliver it, we'll deliver it in the same manner where we'll create an ICMT and deliver the ICMT to the client directly. They will not have access to the cloud on our cloud.
Sounds great. And I know we're at time, but just one very quick question asking about if you have technical questions, who can you route it to? So if you look for Autodesk customer support, our customer success team, you can reach out to them for with your technical questions pertaining to any of our solutions. So that is that, and we're at time. So Regina has kindly posted both of our emails here. So if anyone has any follow-up questions, comments, or feedback, please feel free to reach out to us. I just want to thank Mary very much for joining us today and providing us an excellent presentation on some of the national case studies that she has been involved with. And yeah, thank you, Mary. And with that, I'll pass it to Regina.